Welcome to Swami's classroom. In this lecture, you will learn about area moment of inertia. Why it is so important? When you go to next course, Mechanics of Solids, you will learn all about stresses. The stress is a function of this moment of inertia. You are assumed to know how to find the moment of inertia because you will be using that to calculate the stress. That's what helps you to find the strength of any material. So here the area moment of inertia, we will learn how to find that using the table method what we use in the centroid. If you don't know how to do that, you can go and visit the centroid lecture. You can learn all about that. And before we get into area moment of inertia, let us review the parallel axis theorem. Usually you learn in your class. The parallel axis theorem simply tells if you know inertia about one axis, you can find the inertia about other axis that is parallel to the given axis. For example, here, the little x and capital X, they are parallel to each other. If you know the inertia about the capital X, how we can find about the little x? Simply inertia about the capital X, which is given, plus the area of the shape times the y bar square. The y bar is the centroidal distance of the shape, right? The vertical direction. Similarly, if you know the inertia about capital Y axis, inertia about the little y, we can find because both are parallel to each other. They are apart from x bar. So I small y is I capital Y plus area times square of the distance between them, which is x bar square. So that gives the parallel axis theorem. The Ix, you know it is 1 over 12 bh cube. That is inertia of the rectangle with respect to the centroid. Iy is 1 over 12 hb cube. B is the base, h is the height. So that's the fundamental formula. Now, what is the area moment of inertia? The centroid, we defined it as the first moment of area. Here if you see, the area multiplies with square of the distance. So area times distance is the first moment. Area times square of the distance is a moment of the moment, or ay times y, or second moment of the area. So the definition of area moment of inertia is second moment of the area. Now let us see for any complex shape, your Ix can be written as summation of Ixi plus aiyi square. So I capital Xi is centroidal inertia about the x-axis of the ith element. Ai, ith element area, yi is the y coordinate of the centroid of the ith element. Similarly, Iy is sum of I capital Yi plus Aixi square. And Ixy is defined as the product of inertia is sum of Ai, Xi, Yi. Now let us take a simple example. The L shape, it has 6-inch width and 6-inch height, half an inch thickness. Then we'll have a simple element, the table method, divide the shape into two elements or two simple rectangles. So for the element 1, we have the area and centroid of the element 1 with respect to xy axis gives you the xi and yi, x coordinate, y coordinate of this element C1, say. Same here for the element 2, the area of the rectangle 2 and centroid of the element 2, the second rectangle, with respect to xy axis. It's called as C2. Just the coordinate of C1 and C2. Okay? Those are given in the xi, yi column. Once you have these three columns, the rest of it is simple. You just multiply ai times square of the xi, you get this column. And same way, ai times square of the yi, you get this column. Multiply area X and Y, all three columns, you get this column. So simply you can calculate those values. Now this I capital Xi, I capital Yi are the inertia of each element about its own centroid. We saw the formula just before. I capital Xi is 1 over 12 dh cube. That is 1 over 12 hb cube. So you know the values. Simply substitute for b and h. We can fill out this column and similarly that column and simply add them up. Now to find the Ix, we have the formula sum of Ixi plus Aiyi squared. So sum of this number, Ixi, and Aiyi squared, which is 6.9948 plus 29.2344, you get 36.2292. And the Iy is sum of Iyyi, which is 9.0573, plus sum of Aixi squared, which is this value right here, 27.1719. So summation gives you 36.2292. The unit for inertia is inch to the power 4 because it's the area times square of the distance. Area is inch square, square of the distance another inch square. So the unit is inch to the power 4. So we can easily calculate area moment of inertia of any given complex shape by first dividing the shape into simple elements, rectangles, then calling each rectangle as one element, then finding the area of each rectangle, and finding the centroid of each rectangle with respect to the given reference axis. Once we have those data, then simply complete the table and substitute in the formula, you will get area moment of inertia. So that completes the lecture. Happy learning.